Hello and welcome to our virtual Lunch and Learn today. We will be talking about industrial awareness and network. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Nick Rowe, Network Engineer out of our Columbus, Ohio location. Out in the comment section, ready to answer questions today is Chris Gentry, Network Engineer out of our Norcross, Georgia location. We'll also have a Q&A portion at the end for Nick to answer your questions in more depth and have a little Q&A portion at that time. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us today. As you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining, welcome to our virtual Lunch and Learn Industrial Awareness Network. Let us know where you're tuning in from in the comment section. We'll be looking for your questions as you have them in the comments while our presenter, Nick, highlights sensitive industrial protocols and networking for a more efficient and effective plant floor. Our specialist, Chris Gentry, is ready to respond to your questions in the comment section as we go along. We'll also have a Q&A segment at the end of Nick's presentation. If you'd like to reach out to us afterward, or if you have further questions for Nick, you can always send us an email at mcmclive@mc-nc.com. Be sure to let us know which session you attended or that you're watching as a recording, and we'll direct your questions to Nick. We'll also have that email address on the screen at the end of the presentation as well for you. All right, it looks like we have a number of attendees with us now, Nick, so I will pass it over to you.
Good morning, everybody. Again, I am Nick, and today we'll be focusing mostly on the plant floor, kind of your networking, and then also protocol awareness focused towards that industrial space. Keep in mind during the presentation that kind of keep these questions in the back of your head. Is your network being handled by IT? Where is that cutoff point? As well as maybe some network issues you're having, whether communication seems slow between a controller and the HMI or any of your point IO that's out on the floor. Also, maybe you feel that it's just congested. Things aren't happening the way they should. Also, keep in mind, maybe it's by an OEM or somebody who's building a machine and placing it on the plant floor. How many times have you seen where a switch or a network device kind of just gets put into a panel, turned on, and now no real configuration placed into it? Or, better yet, how many times have you seen like a little unmanaged switch, thrown in there? Maybe you'll find a little Netgear or a little Cisco unmanaged switch, a little Hirschman Spider. Something that's just kind of a plug and play feature into your network panels. All these kind of questions in the back of your head can lead to a deeper dive into your network as to what is really happening with the communications. Are they getting there in the proper response time that you're wanting, as well as if they're getting there at all. So today, how do we get there? IIoT is growing, so your Internet of Things is growing. You're wanting a more robust network, more things are getting connected to the network. But with that, how do you keep a robust plant floor with all this analytics and all these systems that are reporting back to your financial department, your accounting, as to your raw materials being used or any type of scrap that's being measured? All this is communications being added to your plant floor. So today we'll kind of focus on keeping your plant floor operating in a robust way that it should, as well as getting those analytical data sent back to the IT side for whoever's measuring that type of data. Also, how do you prioritize that information, whether it's segmenting your network or putting in a different type of switch? Those are all things to measure, to keep an account for creating this this chart here on the right, your robust network. Keep things time critical, network security, keeping the internet away from from the plant floor, or at least keeping it safe from any type of cyber event that could occur. And then most importantly, how do I keep my safety equipment operating at a time critical need that the safety of the operator is also taking into account? So we're going to go ahead and take a start here with industrial protocols, kind of the critical components. From here, we'll lead into how to implement, make these aware. But this is kind of the focus here of this presentation is this industrial protocols that keep your operators safe, your machines operating correctly, and keep your plant floor from potentially having as little downtime as possible. So these two protocols, SIP and PTP, are pretty close to mandatory for your manufacturing floor. You know, the SIP protocol may be a little different if you're using Siemens, but for this presentation, we're kind of going to revolve around Rockwell with the integration of Siemens, and you know, this can always take into account for prioritization of your CNC machines, any type of plasma welders or anything you might have out there. So SIP is your industrial protocol it's used by your PLC. It's used for the handshake between your PLCs and your HMIs as well as your IO. It's kind of your priority one communications, like Ether IP would be on the IT floor, or for device net or control net. It's kind of when you look into the network, if you take any kind of deep dive, it's the protocol you should see most of. And then the other sensitive kind of mandatory one that needs to be evaluated and prioritized is PTP. This is your time synchronization protocol. You see this a lot with drives, motion, safety. It's kind of like a compass or a grandmaster clock for the plant floor. Devices look for a grandmaster, whatever you appoint to be your grandmaster, and they use that for your time reference. So in your logic, if you have, you know, machine A needing to start at a certain time and end at a certain time, and then that's where your next step or your next process in your line starts, then robot B needs to start at X amount of seconds after, or milliseconds after robot A. If PTP is not kind of prioritized or a grandmaster set, this clock or synchronization can get kind of out of whack. It can get misadjusted. So if machine A starts, say, you know, right at 1 millisecond, and then in 5 milliseconds, robot B is supposed to start. In that time, if a grandmaster is not set, and maybe you have a power surge or something, you know, causes a delay, a hiccup in your network, kind of like I mentioned before. You know, robot B may not start 5 milliseconds after robot A, or it could lose its tooling altogether, and you know, the robot could be out of alignment and then crash into other ones. And maybe if you're in the automotive, it could drop a transmission, drop a chassis. You know, or if you're in food and beverage, it could, you know, not package the material correctly, or if it's a palletizer, it could drop a pallet full of, you know, ready to go product. So it's pretty critical, and it's definitely something that needs to be acknowledged on the plant floor. Some other industrial protocols to take an effect that are typically your IT protocols that you'll see out there that don't necessarily need to be on the automation floor, thus improving your network health. Letting the PTP and the SIP take priority if you can kind of to put these other protocols into check. Your TCP keep alive, for instance, DHCP. On the automation floor, DHCP isn't really a protocol that you'd like to see, as it's a floating address. Typically, you see everything statically set for communications. Multicast, you want to limit that multicast traffic the best you can. There are needs for it. If you've got drives that are talking to multiple devices, obviously that one device needs to be able to multicast to the other ones. But being able to encapsulate and segment that traffic to to more feasible means that it doesn't interfere with the rest of the communications. EIP warnings, you can help by, those can be set off by multicast and another number of other protocols. IPv6 currently is not a protocol that's being used on the automation floor, so it's another one that you can go ahead and turn off. So maybe you're using HMI that's using Windows 7, Windows 10. You can go ahead and uncheck that, and that multicast burst that'll occur, whether it's IGMP or another protocol, it won't interfere with the rest of the network if you uncheck that box, and it's pretty simple to do. A few of the others that are out there, FTP, you see a lot of those on your HMIs, your panel views. SSDP, which is a plug and play feature. There's two areas this can hit, right? It can be your multicast, because the SSDP is saying, I'm out there, but also the security. So if you have a HMI that has SSDP, it's a plug and play. It's the learning feature. So you plug a mouse and keyboard in there, it automatically looks up the drivers and such. But you can look at it from the safety and security side. Maybe somebody maliciously has a USB. They come, you have SSDP enabled, and they plug it right into your HMI. Upload whatever malware they have on this USB. If you disable SSDP, it prevents them from doing that action. By understanding these network protocols and how to isolate, how to turn them on and off, you can see up to almost a 50+% drop in your network traffic, making your network more robust and less congested, less downtime, less faults where it's stopping your production lines. So from here, we're going to move into your how to get this done. So this is kind of your how do I implement, how do I isolate those protocols we just talked about. If anybody's out there, do you know what this is? It's the CPWE. Are you familiar with it? How to place your equipment, how to segment, ideas like that. Also, if you're making your greenfield or you have a brownfield out there, how do you design your network to kind of model this or re-architect? If your network is all unmanaged switches, not set up, and you're wanting that robust managed network where you have visibility and control of your network, how do I re-architect to model this Cisco, Rockwell, Purdue model? The answer is it's you can, but every facility, every manufacturing environment, in my opinion, is going to have a customized version of this. This is the ideal where you want to get to. But maybe if you're re-architecting, you can't get this perfect. So you're going to have a customized version of this. Maybe you're going to have a little different industrial DMZ. Maybe your layer 3 switches aren't going to be set up for horizontal stacking, redundancy. However you feel that your network is, or you can get it accomplished by any type of services area that can help you do this, or if you're able to do this in-house. It's a great model to try to get your network to look like and be as robust as possible and secure. Switching. So how do we implement these protocols and this protocol awareness? There are industrial switches out there. So typically, the IT, you'll see a lot of Cisco catalysts out there, 48 ports. They're a robust switch, but they're not industrial aware. And by industrial aware, I mean understanding and prioritizing these industrial protocols. So SIP, PTP, Siemens, so your Modbus or Profinet. These switches that I have kind of displayed here in front of you, Stratix over here on the left, your gray switches, your Hirschman, which are the blue in the middle, and then your Cisco industrial switches. There's also, the commonly one we see out there is also your Phoenix Contact. All these switches are industrial aware and kind of hardened for that industrial environment, both temperature and climate, which is another kind of concern we'll go into after this. Your Rockwell Stratix switch is, in my opinion, kind of for the protocol awareness, Hirschman and the Stratix switches are definitely your top two that I would kind of lean to. They're going to understand your PTP as well as your industrial. They're going to learn. They're going to learn your industrial network. They're going to learn the communications. They're going to learn the industrial equipment. So your PLCs, your HMIs, your point IO, your robotic cells, and it'll prioritize that communication as it learns it. So it'll understand, with a little configuration that your PLCs, they're going to be top priorities, and they're going to communicate with your HMIs and your point IO. And then anything else that may be floating around there, maybe you've got a supervisor's workstation that's attached to the network that has a HP printer. That's going to kind of be set to a lower priority to let the actual manufacturing tasks take priority. The Strax, you also see the smart ports, which you can actually set, automation device and industrial switching as kind of as a smart port, the actual port settings itself. Each of these can handle your segmentation very well, the same as you would see kind of in any other manufacturer switch. The thing that they do different is, again, they're industrial aware. So you can VLAN and segment with all three. And it's a very robust way to create that Purdue model that we see here. Again, I'll bring it back up, kind of this layer 3 area, and then your distribution stack. These switches, again, they learn your network. Kind of can't emphasize that enough, that it learns the industrial equipment and helps prioritize that in kind of in your typical quality of service. Other ways you can segment, of course, you can air gap, physically separate maybe your IT space from your OT space, or physically separate your lines or your areas of the plant. But to create that robust network that we kind of saw on slide 1, how do I get all of my analytical data out of the plant floor without impacting manufacturing, is you kind of implement these models of switches that are industrial based and add your VLANs and your subnetting, as well as your ether channels. So to kind of give you an example of this, a manufacturer implemented industrial switches, but they didn't configure them. They just kind of set them up. They're like, oh, we'll put in some VLANs, but they didn't change their native VLANs. So what everything kind of resides on. Topology. This is what this is here. It looks, there's a lot of devices, but it's clean. You got your switches kind of at your level 1, switches at layer 2 and layer 3. But again, they didn't do a lot of configuration. They kind of just plugged them in and, said, I want one line on VLAN 1, another one on VLAN 2, 3, so on. And then the backbone of all that still resided on the same native VLAN across all communications. So topology-wise, it's segmented. So let's take a look at the logic communications. This is the communication standpoint. So because it all resided on the same native VLAN, even though there was multiple VLANs in place, this is how everything communicated. Everything talked to everything. So congested, a lot of traffic, and your process from an HMI to a PLC, it could have been around 50%. You push the emergency stop button. Well, it may or may not get to the PLC to stop whatever area it's being controlled. If you're in a robotic area, you've got these large robots that are moving transmissions, pallets, any type of large equipment, making it pretty dangerous. If you have any type of presses out there that somebody actually physically has to put their hand into a press to set the screws, hit the green button, and it kind of presses it in place. The light curtains, the safety mats, those would be of concern. So now that we've kind of talked about how to segment the network, how to implement industrial switches that are protocol aware, let's kind of go into another area of the physical media in place to get these switches connected to each other, as well as getting any type of connectivity down to your IO, your robots, and also back to IT. So there's not just network congestion, so your logical side that could be causing delays on your network. It could be the cabling, it could be the routing, grounding and bonding. So if you're using shielded or versus unshielded cabling, we'll look at that. So there's kind of 4 topics here to go through: cabling, routing, conduits and cable trays, and grounding. That we'll go through a design that we have done in the past that kind of lays these out, and we'll talk about them. But keep in mind the Panduit mice rating. Mechanical, which is your shock vibration, and it goes from grades 1 to 3, so M1, 2, and 3, and you'll see at the top, there's an arrow that says office to industrial. Ingress, which is your water and dust. Do you have any open ventilation on the plant floor? So a lot of times you see like bay doors. So you've got trucks that come in and you load equipment, any type of maybe manufacturing equipments around those doors or anything like that. Climate and chemical, any type of wash down areas. Maybe you have alcohol tanks with stainless steel waterproof control cabinets that you regularly hose down the area. And then electromagnetic, robotic cells, drives, motion, something that it spins up and gives off an EMF. And again, you kind of rate these between M1 to M3 based on the impact that it'll have to the environment. Cabling, we'll start kind of here. It's do you have the right cabling in place? So you've got your shielded RJ45s. You kind of see that picture there, where the actual the male jack is shielded itself. And then to kind of further that, I know with like Stratix, the actual port is shielded. So that kind of keeps any type of EMF from interfering to the other ports. You can also use, like, maybe you've got shock and vibration, so you can use your M12 adapter, your M12 Ethernet adapter. That actually kind of screws into the port. So if you've got, if you got like a robotic cell that's moving pallets, or a press, or any type of high vibration motion, you can always use an M12 that'll further secure that Ethernet connection, where your RJ45 with enough time and vibration could wiggle or break the pin of that sort. To keep in mind also with your shielded is that you keep in mind that both sides should be shielded. If you only shield one side and you only properly ground and bond one side, it's kind of like creating a car antenna where you get a lot of signal and it's all being channeled into one cable. We'll go into grounding and bonding here at the end, and we'll talk a little bit more about that. But that's also something to keep in mind. Also, with your fiber, you can go through your multi-mode, single mode, ST, SC, and LC. Kind of depends on what layer you're putting your fiber. So if it's kind of at the line and it's all inside of an IDF, you can use LC fiber patch cables. But getting there, typically, you can run it into Conduit to get it down to maybe your MDC. And then from there, you use a different type of fiber out to your IDFs, and then so on. Maybe you've got fiber going right down to your control panel. A lot of times, I would prefer to use OM4 double jacketed armored cable. It's indoor-outdoor rated. It's pretty durable. So if you've got it just hanging with J-hooks and you're in a warehouse environment, maybe a forklift hits it, it's less likely to break the fiber. You might crack it if it's dragged long enough, but if you catch it pretty shortly, it's pretty durable. And it's a great way if you're running in between buildings, or if you're going through cement walls, things of that sort. And all these kind of different cabling and things we'll talk about a little bit further on here when we see routing and cabling, and we'll further go through that. So cabling and conduits. As I mentioned, kind of where you're going, and rated for that mice environment that we discussed in slide 1. So here they're using an OM3 indoor graded fiber, and that's going to your floor IDF. Typically, that's going to kind of be away from your line, and you'll have maybe that's kind of one of the crossover points for where IT and OT maybe handoff if there's not that industrial space, or maybe there is. But things to notice here in the middle, that red line, you see that's a 600 volt rated cable. It's going into industrial enclosure that's using shielded jack modules, so it's shielded on both sides. And then the 600 volt rated cable is also shielded, and it's a more robust cable for high EMF environments. Motion, so like a lot of times you see it in drive panels, or you see it around robotic cells, which in this case you see the robotic device on the far right. So they're going from a OM3 indoor fiber cable, so it's not double jacketed, it's going into a fiber, maybe a fiber fan out kit to another IDF. But where the EMF kind of starts interfering with cabling, they're using a 600 volt rated cable. And it's in a copper, it's in a cable tray versus a conduit. That's going into your control panel, where they're using, again, they're using shielded jacked modules. And then another 600 volt industrial rated cable that's going to the robotic device itself as an M12, because there's a lot of vibration. So on your mice rating, it's probably an M3. It's the most vibration, the most shock rated area you're going to get. All the conduits in this case is they're using J hooks for fiber, and then they're using just a wire grid for the routing of the cable from the IDF to the control zone enclosure. Other ways to do conduit, if maybe you don't want to go down or you can't afford the armored fiber, is you can run a conduit, or you can run just its own type of kind of isolated fiber tray. And then the same with copper. If you necessarily don't feel that you need the 600 volts cabling, but you don't want interference from any type of EMF, or maybe you're concerned, you can always run designated conduit and run all your fiber that way. Or maybe if you have like the ingress, so if you have the water or the chemical, maybe you can't have exposed cables for a wire grid. You have to run it in conduit. All these are things to think about when you're creating your new areas, or if you're having concerns on your plant floor, maybe around your robotic cell. Maybe every time your robot first turns on or the drives spin up in a certain area, maybe you're getting a fault or things aren't starting the way they should. This is the physical media is definitely a good way to start. Do I have the right rated cabling? Is it shielded correctly, or is it unshielded and I need to run it in a designated conduit? Things of that sort. Which this can kind of lead into your routing. This, maybe you can't have the 600 volt rated cable, or you already have the cabling in place. Routing can come into a huge play. You can kind of see here, based on the CPWE model for the model that was shown before, this is partaking in redundancy. So you've got your orange and your blue lines creating that redundant path, allowing, if one line breaks, you have another cabling route that'll take its place. Another good use of routing is maybe you're running Ethernet throughout your plant. You don't want to use fiber. You don't have any runs that are over 300 feet that maybe you don't need to have fiber. You're just using your unshielded Cat6, Cat6A, but you have to go across or around a robotic cell or high vibration or through an MCC area. Routing can play a huge play in that. Keeping the interference and the EMF away from that cabling is you can always go a different route or have a redundant path, or using the proper cabling in that routing area. All this kind of leads into also the grounding and bonding. Conduit has some great articles on how to ground and bond. If you have concerns about grounding and bonding, is it done right? Maybe you still feel that it's just an area of concern. We've had customers that have done, they couldn't get the grounding and bonding the way they felt was correct, or the facility was old enough that they couldn't go back and rip up concrete or do things to get the plant ground separated from your telecom ground, which is kind of the best practices to have two separate ground. Um, Kind of very rarely have I seen that happen unless it's a greenfield build. Um, you can go with the unshielded cable, but run it in a separate conduit. Again, all things kind of play into factor there. Do I have the right cabling? Do I have the right conduit? Am I routing around any high EMF areas? And then am I just doing the simple grounding and bonding, say for the switch or the PLC? Um, it's it's very important to make sure you have the ground, one for the safety of the equipment, but also to keep those EMFs. A lot of times EMF is one thing that we see that can be fixed by a cable, or it can be a jack. Maybe you have a shielded jack, but the some of the ends, it's coming unseated from the male adapter. All things can play a factor. Physical media is probably the one area that is skipped the most, and typically it can be is the one area that can fix your problem or improve it most easily. Maybe the switch configurations are a little out of the wheelhouse, or it can't be done right away. So you can always kind of look at the physical media. I can swap a cable faster than you can swap or configure a switch kind of approach. Here in this picture, you can see that there is separate grounding. The colors are off a little bit. There's a yellow, which is your telecom ground. Is your plant ground. So it's kind of your panels, maybe your UPSs, and then the green is your telecom ground. All of which go into, they have multiple stages of grounding, but then go into your kind of your universal plant ground, wherever that may be designated. My kind of focus here that I wanted to point out is that telecom ground is, if you're having any type of concerns with cabling, shielded cable, is it grounded on both sides? Best approach, you get a grounded port, a shielded port. So like your Stratix is already built in, or you can purchase, you kind of saw back here, you can purchase the shielded jack modules, and then having your shielded male cables is making sure that they're shielded and grounded on both sides. And if you're of concern, you can always get with an electrician and check that and make sure it's correct. I do want to go back to the mice rating because, again, with the noise and shielding, we'll kind of, now that we've brushed on all these topics, we'll kind of, we'll take a look how each of those can play a factor. Shock and vibration, again, your mechanical. Your M3 for here could be fiber, because fiber is not affected by EMF or a lot of shock and vibration. So maybe you have an M3 rated environment. So fiber is definitely an option. You can also look at using your M12 adapters. So we looked at the cabling, and then your ingress, water and dust. So like I used in my example, maybe you have bay doors where you're loading and unloading product. You have M12 adapters because it's raining, maybe it faces the west and you've got a lot of rain and snow that comes in when trucks are backing in and out. So you can use a airtight, watertight zone enclosure and have M12 adapters to that area. Same type of example for your climatic and chemical, maybe it's a washdown area. You can use that same type of panel with your M12 adapter, so it's not being affected if you have to spray it down. If it gets condensation, water, a lot of dust. And then your E3. So this is, all these threes are kind of your industrial production area of the plant. So your electromagnetic, your EMF, your robotic drives, you're using again, fiber, because it's not affected by EMF, shock vibration. And then also your 600 volt rated cable. M2 line of things could be like your plant floor IDFs, where you're using shielded cable, you're running things in conduit versus cable trays. You're going that in between from an IDF to a zone enclosure. You're actually not in the heat of things at your M3 production area of the plant. And again, your M1 is kind of your office space. Go into your supervisor's area if you've got a large plant and you've got a station where all your supervisors go and they kind of punch in their data and send their analytics back. Or if you have any supervisor offices that are on the production floor, but they're still communicating or have insight to that automation equipment. A lot of times you see in engineering workstations that are kind of in these that have links both to IT and OT. So you could use your M1 rated devices. Again, everything that was covered, cabling, routing, conduits, grounding, there's documents within Panduits that all adhere to, they'll label things, this is an M1 or an M2 or M3. If you want further knowledge into, well, maybe I feel that my environment's all level 3 rated, what kind of things should I consider? With that, we'll kind of lead into the Q&A. If there's anything out there that has been answered or needs to be answered. Some ideas that are possible questions is design ideas. How do I mold my environment or re-architect my unmanaged environment to kind of resemble that CPWE model? Industrial assistance, maybe there is your network's being handled by IT, and you feel that the SIP and industrial protocols really aren't being prioritized. It's just kind of a flat network like you saw in the logical communications. Again, that kind of leads into the protocol awareness. Maybe I need my timing set up. I've got a lot of robots out there. I got a lot of drives in motion that I want to make sure my employees are safe and have that protocol awareness. Any type of network deep dives. What are my switches configured? What can they handle? What are recommendations? Communication wise, what's really out there? What's happening on my floor? Again, I had mentioned that when you look at the network health, you should kind of see that SIP kind of being one of the top priorities out there. 8 times out of 10, 80% of the time we see a lot of broadcast and multicast, whether there's Rockwell or automation devices looking for other automation devices, or automation devices that aren't out there that maybe just weren't removed from the logic. So with that, I will kind of hand it off to Rachel.
Sure, thank you, Nick. We don't have any live questions at this time, but we'll allow a few moments here at the end for anyone that might have some follow-up questions based on some of those examples you just gave us. While we wait to see if anyone does have questions, I'd like to remind you that you can always reach out to us at the email address there on your screen, macandmaclive@macandmac.com. If you have a question that comes up after you have attended this session, or if you're watching this as a recording and you think of something you want to ask Nick directly, please do use that email address and we will get that question to him so he can reach out to you. All right. With that, I'd like to thank you, Nick, for this wonderful presentation. Lots of really excellent information in there. And thank you to Chris for being our resource out in the comment section today. And of course, thank you to all of our viewers who joined us today, so very close to the end of this year. We appreciate your time, and we hope that this session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content like this, and we look forward to seeing you live again soon. Thank you, everyone. Have a great day.